What's up, y'all? Pastic here again, and here we are in section 4.6, the final section of Unit 4, Solving Inequalities. And our goal for today is to solve and graph absolute value equations and inequalities. So the first one we're going to look at says solve and check, and it is the absolute value of a minus 3. So the first thing you're going to want to do is make sure you know the definition of absolute value. And the definition of absolute value is the distance something is from 0. So the absolute value of a tells you how far a is from 0. All right, other than that, there's a couple different things, but let's start it off kind of normal. Got the absolute value of a minus 3 equals 5. First thing we're going to do is, as usual, we're going to go plus 3 on both sides. And after that, we're left with the absolute value of a equal to 8. So what you have to do here is picture a number line. You have to think, all right, what has a distance to 0 that is equal to 8? Well, if I'm looking at a number line, there are two numbers that are 8 units away from 0. 8 and negative 8. 8 and negative 8 are both 8 units away from 0. Therefore, when we have the absolute value of a equal to 8, that means that a could be 8 or a could be negative 8. A could equal either one of those because both of those are 8 units away from 0. So let's do a quick check. We'll check 8 first. So the absolute value of 8 minus 3, does that equal 5? Well, that's the same as 8 minus 3, which does indeed equal 5. And then the absolute value of negative 8 minus 3 equals 5. The absolute value of negative 8 is also 8 units away from 0. And those are both correct. So we do know that these are indeed our solutions. The next problem says solve the absolute value of 3c minus 6 equals 9. So in this one you have to think to yourself, okay, the entire thing on the left is equal to absolute value of 3c minus 6. That whole thing is going to equal to 9. So you have to think to yourself, what two things have an absolute value of 9? And kind of like the last problem, we said the absolute value of a equals 8. That means it could be 8 or negative 8. So this time, 3c minus 6, which is in the absolute value, could be equal to 9, because that has an absolute value of 9. But 3c minus 6 could also equal to negative 9. Those are the two things that will have an absolute value of 9. So now in order to finish the problem, it's actually not too bad. We just have to solve both of these two-step equations, and the work should be the same for each one. So we've got plus 6, plus 6, plus 6, plus 6. So 3c is equal to 15, and 3c is equal to negative 3. Divide by 3 here, divide by 3 here, divide by 3 here, divide by 3 here. And we have c equal to 5 or c equal to negative 1. So then if I want to do a quick mental check, go back up here. 3 times 5 is 15. 15 minus 6 is 9, and the absolute value of 9 is 9. So this one works. Quick mental check on the other one. 3 times negative 1 is negative 3. Negative 3 minus 6 is negative 9. And the absolute value of negative 9 is 9. So you should probably do those out, maybe show one. For now, I'm just going to do it kind of mentally. But it's always a good idea, to check your work and make sure that your solution is correct. It will give you confidence and allow you to move forward feeling good. Next one. The next one says, absolute value of y minus 5 is less than or equal to 2. Graph the solutions. So for this one, you have to take a little bit of a side note, and you have to think to yourself, all right, it says the absolute value of y minus 5 is less than or equal to 2. So you have to think, what numbers have an absolute value less than or equal to 2? So in this one, it helps to draw, whoa. It helps to draw a number line to sort of figure out what numbers we're talking about. So here's the number line, put 0 in the middle, 1, 2 here, 1, 2, negative 2 here. So what numbers have an absolute value less than or equal to 2? In other words, what numbers are within 2 units from 0? So you could be somewhere between 2 and 0 this way, or you could be somewhere between negative 2 and 0 this way. So what are we really saying? We want to split that up into two things. We want to say the absolute value of y minus 5, or y minus 5 is less than or equal to 2. But it also could be greater than or equal to negative 2. That would include this part right here. Greater than or equal to negative 2. So we're going to put that on this side over here. So now what we have is a compound inequality, and this should represent the exact same thing as this absolute value inequality up here. So solve this like usual. Plus 5, plus 5, plus 5. 3 is less than or equal to y, which is less than or equal to 7. And now it says to graph our solutions. So to graph our solutions, we're going to draw another number line. We'll start off with 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 10. We've got two less than or equal to symbols at 3 and at 7. So we're going to go ahead and fill in a circle here. No. Nope. So that's a filled in circle. I'm having a hard time here. And then a filled in circle here. And then what are we going to do? We have to be between those two, 3 and 7, so we have to connect it. So this is a filled in circle here and a filled in circle here. And that is our graph solutions. I apologize for the thing popping up. I'm doing this on my laptop at home and I'm having some difficulty. So let's check to make sure we have the correct area. So if we put it in 7, back up here, 7 minus 5 is 2. Absolute value of 2 is less than or equal to 2, so that works. What about 3? So I'm checking the endpoints. 3 minus 5 is negative 2. The absolute value of negative 2 is 2. 2 is less than or equal to 2, so that works. And then what about a number in between? What if we plugged in 5? 5 minus 5 is 0. Absolute value of 0 is 0. That is also less than or equal to 2. So it looks like we've got the right solution set graphed here. All right, so that's solving an absolute value inequality right there. Just to go back to this, it will be different if this symbol is greater than or equal to. If the symbol is greater than or equal to, what you're going to have to do is set up two different equations and solve them, but we'll handle that at a later time. Last one on section 4.6, and that is it for the unit. So this one says the ideal diameter of a piston for one type of car is 88.000 millimeters. The actual diameter can vary from the ideal diameter by at most 0.007 millimeters. Find the range of acceptable diameters for the piston. So when you do a problem like this, and this is actually a really important type of problem, this is involving the idea of tolerance. Tolerance in math is basically an error limit. So it's saying you can be off by this much in either direction. And in this problem, the tolerance is 0.007 millimeters. They're saying that when they build this piston, they're aiming for 88 millimeters, but it can be off by 0.007 on either side. And if it's off by more than that, then they have to reject it because it will make the engine part fail. So let's go back and reread and let's mark our information. We've got the ideal diameter of a piston for one type of car is 88.000 millimeters. So we'll call that our target. Our target, which is our ideal number, is 88.000 millimeters. The actual diameter can vary from the ideal diameter by at most 0.007 millimeters. So we're going to call that 0.007 millimeters. We're going to call that our tolerance because that's what we can tolerate an error of on either side. It says find the range of acceptable diameters for the piston. So you could probably do this logically. You could probably think, okay, it's going to be 0.007 high and then 0.007 low. So we could probably figure those out. But typically what they want you to do is to write this as an absolute value inequality. And it's just something to be a little bit more formal with your work and your presentation. So we're going to identify a variable, d. D is going to equal the actual diameter of whatever piston we've created. So D is the actual diameter of the piston. I apologize for my writing. It's much more difficult to do on my laptop than it is on my screen at work. So from there, we're going to say, all right, well, what has to happen? Well, what has to happen is that this actual diameter has to be within 0.007 millimeters of 88. So the way you set this up is the absolute value of actual size minus target, and that difference has to be less than or equal to the tolerance. That's tolerance. I apologize again for the writing. So what's our actual? Well, we called that D. So D is going to be first. The absolute value of D minus what's our target? Our target is 88 millimeters. All right, 88.000. You might hear that blue jay in my backyard is going buck wild. And this has to be less than or equal to our tolerance, which in this case is 0.007. So once we have that, we can solve it just kind of like the last one. We can get rid of the absolute value. We can put negative 0.007 over here, less than or equal to D minus 88. I'm going to drop those extra zeros. And now we just solve it with one step. Plus 0.88, whoa, plus 88, plus 88, plus 88. Cancel that out. We have 87.993 less than or equal to D, which is less than or equal to 88.007. So what we just found out, and we probably could have done this logically, but again, I'm teaching you, I'm trying to show you a strategy and a formality that you can use to apply to other problems if they become more difficult than this one. So what we found out is that our tolerance can be at lowest 87.993 millimeters and at most 88.007 millimeters. And that is the range of acceptable diameters for this piston piece. I believe that brings Unit 4 to an end. Thanks for sticking with me. And again, I apologize for the chicken scratch writing, but doing the best I can on this laptop here, y'all. I will catch you next time. Take it easy.